Now, the first image from the world's most powerful space telescope, James Webb, is here.
The James Webb Space Telescope wasn't built to search for artificial lights, but its incredible sensitivity has often inspired astronomers to imagine possibilities far beyond traditional science. So when reports surfaced that Webb had detected strange, luminous signals from a region known as R2 Swan, a fragmentary comet path in our galaxy that had always been considered unremarkable, the astronomy world was shaken. The light wasn't a natural flare, nor the pulsing of a variable star, nor the scattered reflection of cosmic dust. What Webb detected carried a spectral signature that looked shockingly similar to structured illumination. Light that didn't come from fusion or chemical reactions, but appeared to be deliberately powered and maintained. R2 Swan had always been classified as a faint, icy drifter, a leftover piece from the early building blocks of the solar system. Its orbit was well known, and by comet standards, it was nothing special. But the James Webb Telescope's unmatched infrared sensors picked up tiny points of brightness on its surface that simply shouldn't have been there. These signals were faint, yet oddly regular, an illumination pattern far more precise than any naturally occurring process. While comets and asteroids usually reflect sunlight in random patterns as they tumble through space, the lights on R2 Swan behaved differently. They pulsed. They followed intervals. Their intensity didn't match anything expected from reflected starlight. What makes this so significant isn't just the hint of artificial origin, it's the scale. These weren't massive, city-sized lights like those imagined in science fiction, but more like small beacons, pinpricks of light appearing in clusters on the comet's surface. Webb's data showed these lights turning on and off in repeating patterns, even as the comet fragment spun and drifted. It's as if something, or someone, was operating small outposts on the surface, controlling light not to signal other spacecraft, but perhaps as a byproduct of some energy usage. Naturally, astronomers questioned the data, considering contamination, instrumental errors, or even cosmic ray interference. Webb's instruments are so sensitive they can pick up incredibly faint noise. But repeated observations confirmed the lights were real. The patterns persisted over multiple viewing sessions and weren't affected by changes in Webb's position. Even more curious, the brightness appeared only in specific, narrow parts of the spectrum. Much like LED lights on Earth, which emit concentrated wavelengths rather than the broad spectrum glow of natural sources. The discovery electrified the scientific community. It hinted at something long speculated, but never seriously confirmed: artificial light beyond Earth. The implications are enormous. If these lights are truly artificial, then this seemingly ordinary comet fragment may actually host some kind of technology. That raises a big question. Why would a comet have lights? One theory suggests the object isn't a natural fragment at all, but an artificial vessel camouflaged in cometary ice. Some advanced civilization could have wrapped a spacecraft in frozen material to hide it among the natural debris of the solar system. Another possibility, the lights are navigational markers, guideposts glowing across the darkness for purposes we can't yet understand. If this turns out to be the case, it means our solar system may already contain objects that have been modified or designed for uses far beyond human imagination. What's especially compelling is the rhythmic nature of the light signals. Natural sources of light, like stars or flaring dust, tend to fluctuate in chaotic ways due to winds, heat, and other forces. But in R2 Swan's case, the timing was sharp and consistent, almost like the ticking of a clock. Some lights maintained precise intervals, while others followed longer, coordinated cycles, turning on and off in near-perfect synchronization. That kind of pattern suggests control, whether by machine, algorithm, or intelligence. Seeing such structured, consistent illumination on the surface of a comet is hard to explain with natural geology, but it makes sense if you consider artificial design. Of course, healthy skepticism remains. The scientific method demands caution, and extraordinary claims require extraordinary evidence. But Webb was built exactly for this: to explore the universe with unprecedented precision. Its infrared sensors can pick up faint heat signatures from across cosmic distances. And in this case, What it found was so strange that denying the possibility of artificiality now feels more radical than considering it. If these lights are indeed artificial, humanity may have stumbled upon signs of technological activity in its own cosmic neighborhood for the first time ever. This changes how astronomers might think about small objects like comets and asteroids. For decades, we've seen them as inert leftovers from the solar system's formation. But what if some of them aren't entirely natural? In recent years, the idea of technosignatures, evidence of alien technology, has gained traction, often focused on grand-scale structures like Dyson spheres. But maybe advanced civilizations don't leave behind monumental megastructures. Maybe they seed the galaxy with small, durable markers. Artificial lights in R2 Swan could be just such a quiet trace, hidden in plain sight among the billions of rocky travelers in space. From a scientific standpoint, this detection reshapes the search for extraterrestrial intelligence. Traditionally, SETI, the search for extraterrestrial intelligence, has focused on radio waves, listening for directed signals from the stars. But artificial light might be just as important, and maybe more enduring. A civilization could stop broadcasting, but a simple automated system producing patterned light might continue for centuries, silently glowing in the dark. In that sense, Webb's discovery is a wake-up call. SETI may need to broaden its view, beyond just listening, to also watching. Given that even modest energy outputs can be detected by powerful instruments like the James Webb Space Telescope, it's no surprise that human curiosity leaps into speculation when faced with a mystery of this kind. Naturally, questions arise about the source of these lights. Were they created by an advanced civilization that passed through our solar system long ago, leaving behind remnants of their technology? Or do they belong to a still active presence, quietly observing or mapping our neighborhood from afar? Though their exact purpose remains unknown, one thing is certain. This discovery has introduced a new level of seriousness to the idea that humanity may not be alone in the universe. What was once a nameless, icy rock, R2 Swan, has suddenly become one of the most intriguing objects in near-solar space. What makes this even more fascinating is that the lights weren't scattered evenly across the comet's surface. Instead, they appeared in curved patterns, almost like sections of a grid. This uneven but seemingly intentional arrangement only strengthens the idea that they may have been deliberately placed. In contrast, natural light reflections are random, scattered based on ice deposits, surface texture, dust, and the spin of the body. But Webb's data showed localized points of illumination that appeared to be strategically placed, possibly in alignment with the object's shape or orbit. Some astronomers were reminded of communication arrays here on Earth, systems where repeating modules are spread out over an area to form networks. If that comparison holds any truth, it suggests that these lights aren't just accidental or decorative. They may be components of a larger, functional system designed with a specific purpose in mind. The discovery also forces us to reconsider our assumptions about distance and proximity. R2 Swan isn't some faraway exoplanet, light years from Earth. It's a small fragment within our own solar system, occasionally passing close to the orbits of the outer planets. The possibility that artificial activity exists so close to home dramatically shifts our understanding of where contact might occur. Suddenly, the idea of encountering signs of alien technology is no longer just a far-off dream linked to distant stars. It becomes something tangible, woven into the very debris drifting through our local space. And with it comes a psychological shift. For centuries, humanity has seen the cosmos as vast and indifferent, with Earth as a lone island of life. The discovery of artificial lights on a nearby object disrupts that story. Even if the creators of these lights are long gone, the fact that their work still lingers is profound. It suggests that intelligent life might not be rare after all, and that its traces may not come in the form of sprawling alien cities, but rather quiet, modest signs scattered across the galaxy. It's a humbling thought that faint lights on a frozen fragment of space debris could be humanity's first real evidence of another civilization's existence. Now, astronomers are faced with the challenge of confirmation. Webb will continue observing, but independent verification is crucial. Ground-based telescopes, while less sensitive, may still be able to pick up related signals. Future missions could be planned to send a probe to R2 Swan, a project that would take years to develop, but one that now seems incredibly compelling. The idea of launching a spacecraft to explore a possible artifact from an alien civilization is thrilling. Such a mission wouldn't just be a study of rock and ice, it could become the first direct interaction with non-human technology. The engineering hurdles would be enormous, but the opportunity for discovery is equally massive. The cultural impact of this detection is just as significant. For the first time, discussions about alien technology are grounded in actual data, not just science fiction or speculation. R2. Swan shifts the conversation from "are we alone?" to "what do we do with the evidence we find?" The lights recorded by Webb transform abstract speculation into observable reality. We may be standing at the threshold of a profound moment in human history, one where long-held myths and ideas are suddenly backed by measurable, empirical data. If the lights are truly artificial, then we've witnessed the first trace of intelligence beyond Earth, a quiet signal glimmering from a piece of cosmic debris. The years ahead will determine how this discovery develops, but even now, the implications are staggering. These lights change the way we approach the search for extraterrestrial life. It's no longer just about looking for distant, Earth-like planets. It's about investigating our own cosmic backyard. The James Webb Space Telescope, humanity's most advanced eye on the universe, has shown that the extraordinary may not lie only in the farthest galaxies, but right here, among the small, cold objects drifting quietly around us. It's a reminder that the universe is not just stranger than we imagine, it's stranger than we can imagine. And within that strangeness, it leaves behind faint lights, waiting patiently to be noticed. The detection of artificial lights in R2 Swan could be the opening chapter of a new era. For the first time in human history, the possibility of alien technology isn't locked behind theory. It's illuminated in the data. If the spectral patterns do point to deliberate illumination, we may be standing on the edge of the greatest scientific revelation of all time. To truly grasp what this means, we must go beyond the astrophysical evidence and explore its ripple effects in science, philosophy, technology, and culture. This is not just a question of what was found, but of what it means. What makes this especially fascinating is the context. R2 Swan isn't a planet brimming with life, or an exotic world in a distant habitable zone. It's small, icy, and overlooked, a frozen remnant quietly orbiting the sun. And yet, that's where the sign emerged. This forces us to rethink our assumptions about where to search for advanced civilizations. For decades, scientists have focused on Earth-like planets with rocky surfaces, atmospheres, and water. But perhaps intelligent beings don't just live on habitable worlds. Maybe they've spread out into the forgotten edges of solar systems, adapting or disguising comets and asteroids for their own use. That idea alone transforms the framework of the search for extraterrestrial intelligence. And then there's the sheer technological complexity of generating light on a body like R2 Swan. It exists in deep cold, where temperatures plunge far below what ordinary human-made electronics can survive. To produce controlled illumination in such an environment would require advanced insulation, exotic materials, or perhaps an entirely new form of energy generation, something we've yet to develop or understand. Even the simple act of attaching equipment to a comet's porous and constantly shifting surface presents major engineering challenges. If the lights detected on R2 Swan are indeed artificial, then whoever created them has mastered technologies far beyond what we're currently capable of. That realization raises not only scientific questions, but deeply philosophical ones as well. What were their intentions? Were the lights created for communication, mining, navigation, or something we can't even begin to understand? One particularly thought-provoking idea is that they might serve as a kind of cosmic breadcrumb trail, placed deliberately to be found. If that's the case, then locating them on a nearby object like R2 Swan is akin to someone leaving a message just beyond our doorstep. These markers could be part of a galaxy-wide system, subtle indicators that a civilization exists without fully revealing itself. Artificial light, after all, is one of the simplest ways to say, "We are here." While radio waves fade and scatter across light years, a glowing beacon can stand out to any telescope sensitive enough to see it. It may not be a coincidence that the James Webb Space Telescope, designed specifically to detect faint infrared signals, was the first instrument to notice this anomaly. That we were able to detect it now, at this point in history, says a lot about timing. Webb was launched during a pivotal moment, a time when humanity is just beginning to shift from being a planet-bound species to a spacefaring one. We're placing instruments in orbit, developing interplanetary missions, and slowly building the foundation for exploring beyond Earth. The fact that we're seeing this now, not 100 years ago, or 100 years from now, suggests a strange synchronicity between our readiness and the universe's willingness to reveal. Perhaps civilizations only leave detectable traces once others reach the technological maturity to find them. From a philosophical perspective, the lights on R2 Swan challenge humanity's long-standing belief in its cosmic solitude. For centuries, religions, philosophies, and worldviews have wrestled with our place in the universe. Copernicus displaced Earth from the center of creation. Darwin dethroned humanity as the pinnacle of life. Now, this discovery might remove us from the position of being alone. To find signs of intelligent activity so close to home is to confront a new reality, that other intelligent beings, whether long gone or still active, exist beyond us. And that changes everything. For some, this realization will inspire wonder and humility, awakening a sense of being part of a much larger cosmic community. For others, it may bring fear or uncertainty, forcing a deep rethinking of our identity, purpose, and future. The sciences will evolve as well. Astronomy, once focused solely on natural phenomena, will begin to include the search for artifacts, relics of intelligence. In fact, a new discipline is already beginning to take shape: astroarchaeology, the study of technological remnants left behind by alien civilizations. R2 Swan may become the first major focus of this field. Engineers, too, will start investigating how artificial lights could persist in such harsh, freezing conditions. What kind of energy sources would be required? How would such systems survive for extended periods? If these lights are powered by highly efficient, compact energy technologies, they could inspire innovations here on Earth. Just as astronomy has previously driven advances in navigation, optics, and computation, this discovery could unlock entirely new areas of research. If the spectral signals from R2 Swan show energy emissions that don't match any known material or process, we may be looking at a glimpse of entirely new physics. Indeed, Webb has already detected unusually narrow band light emissions that look more like engineered sources than natural scattering. This kind of signal may be the first clue in a much larger mystery, one that could redefine our understanding of materials, energy, and the universe itself. In this way, the detection isn't just an answer, it's the beginning of countless new questions. Each one has the potential to push the boundaries of human knowledge. There's also a practical dimension. Humanity has long feared the danger of asteroids or comets colliding with Earth. But now, we may have found one that contains evidence of technology. This shifts our view of these celestial bodies, from threats to opportunities. If intelligent beings once adapted R2 Swan for their own use, perhaps other comets and asteroids could be transformed into platforms for infrastructure. We, too, could one day follow that path, repurposing these ancient rocks into habitats, outposts, or communication relays. The lights on R2 Swan might serve as a subtle guide, showing us how to turn drifting debris into something meaningful. Culturally, the discovery will ripple through art, literature, and the human imagination. For thousands of years, people have looked to the stars and seen symbols, gods, spirits, omens, or guiding forces. Now, one of those imagined lights turns out to be real. Writers and poets will be inspired by the story of a comet whispering across the void through its soft, steady glow. Artists will envision the structures behind the lights, perhaps crystalline towers trapped in ice, or elegant machines glowing against the deep black of space. science fiction will blend with scientific fact, blurring the line between imagination and reality. And for the public, the idea of lights on a comet will forever change how we see the night sky, not just as a distant stage for cosmic drama, but as a place where other actors may have already walked. The geopolitical impact will be just as dramatic. As nations compete for dominance in space, the discovery of possible alien technology so close to Earth could trigger both cooperation and rivalry. On one hand, such a discovery should unite humanity. No single country can claim ownership of something this profound. But on the other hand, the desire to be first, to investigate, to control, or even to weaponize such a find could fuel a new kind of space race. The lights on R2 Swan could become either a unifying symbol or a source of tension, depending on how humanity chooses to respond. And beyond all this lies the dimension of time. The lights detected on R2 Swan may not be the work of an active civilization, but remnants left behind long ago. If that's the case, the comet could be a kind of time capsule, containing technology designed to last through the ages, quietly glowing even as the beings who made it have long since disappeared. The idea that an ancient intelligence, perhaps millions of years older than humanity, could leave behind functioning technology is deeply profound. It suggests that civilizations may rise and fall across vast stretches of cosmic time, leaving behind clues for others to one day discover. In this view, the universe becomes a place where communication happens not through direct contact, but through artifacts, messages in bottles drifting through the galactic sea, waiting to be found. This discovery also challenges how we think about habitability. Humans tend to define livable places in very specific terms: warmth, atmosphere, and water. But for a far more advanced species, a comet might serve just as well as a planet. With the right technology, even the most inhospitable environments can be transformed into centers of activity. This forces us to broaden our search for intelligent life. Instead of focusing only on Earth-like planets, we must consider all kinds of celestial objects: asteroids, icy moons, the atmospheres of gas giants, and even clouds of interstellar dust. Any of these could hold technological signatures, quietly waiting to be noticed. There's also a deeply emotional and symbolic layer to this. Light has always held special meaning for humans. It represents knowledge, life, presence, and connection. To see artificial light shining from a distant object is to feel a connection, an echo of understanding between us and someone, or something else. It's a reminder that the impulse to shine in darkness might be universal. That emotional resonance ensures the discovery reaches beyond the scientific community and into the hearts and minds of people everywhere. From a technological perspective, this could change how space exploration is approached. Until now, most missions have focused on larger planetary bodies or moons. But if small objects like comets can contain signs of intelligence, future missions may shift their focus. We could start sending probes equipped with advanced sensors to investigate these lesser-studied bodies, scanning for heat signatures, unusual light patterns, or electromagnetic anomalies. The entire approach to space exploration might change, from chasing a few grand targets to systematically examining the solar system's scattered debris. Each small rock could hold something extraordinary. There's also an ethical dimension. If these lights are indeed artificial, they may still serve a purpose, perhaps even one that's still active. Interfering with such systems could cause unintended consequences. Humanity must consider how it approaches such a find, with scientific curiosity, cautious restraint, or respectful distance. The question becomes, should this be treated as a research opportunity or as a sacred relic from another civilization? The choice could shape how we interact with the universe from this point forward. Education will inevitably evolve in response to this discovery. Generations raised on the question, "Are we alone?" may now begin their studies with the assumption that the answer could be no. School curricula will expand to include new fields like technosignature analysis, cosmic engineering, and astroarchaeology, the study of ancient alien artifacts. Classrooms will buzz with curiosity and possibility, and students will grow up inspired not just by science, but by the idea that humanity is part of something far greater. The result will be a new generation of scientists, engineers, and visionaries motivated by wonder. Religious and philosophical interpretations will vary. Some belief systems may embrace the discovery as evidence of a richer, more populated creation. Others may struggle with what it means for doctrines of human uniqueness. But in all cases, the lights on R2 Swan will spark deep questions. What does it mean to be human in a universe shared with other intelligences? How do our stories and beliefs fit into a cosmic narrative far older and wider than we imagined? From a scientific standpoint, what the Webb telescope has observed is likely only the beginning. Future instruments, like the upcoming Extremely Large Telescope and other advanced infrared observatories, will aim to replicate and refine the data. Each confirmation will strengthen the case for artificial origin. Researchers will go beyond brightness alone. They'll analyze how the light pulses change over time, examine spectral fingerprints, and study the rhythms of the signals. Every new data point helps build a clearer picture, one that's becoming increasingly difficult to explain as a natural phenomenon. Perhaps most intriguing is the possibility that this isn't a one-off event. If artificial lights exist on R2 Swan, then they may exist elsewhere too, on other comets, asteroids, or even mysterious interstellar objects like Oumuamua. It's possible our solar system is quietly filled with subtle markers of intelligence. Each one would serve as a quiet reminder that the cosmos is not empty, but shaped in part by other minds. This isn't just a singular discovery. It marks the beginning of an entirely new chapter in humanity's relationship with the universe. The lights on R2 Swan change the way we think about intelligence, presence, and technological legacy. They show us that intelligence leaves behind traces, that technology outlives its creators, and that humanity might not be an isolated case, but one piece of a much larger cosmic puzzle. The faint glow captured by Webb may be more than a signal. It may be an invitation, one that asks us to look closer, to think deeper, and to take our first real steps into a universe that's far more vibrant and alive than we ever dared imagine. Beyond the philosophical and scientific impact, there is also a mathematical mystery unfolding. At its core, light is a form of information, and information can carry structure, intention, and meaning. The precise pulses observed by Webb are more than just curious. They invite mathematical analysis. If these lights are artificial, their timing might not be random at all, but instead structured, potentially encoded with information. Just as humans use patterns like prime numbers or binary sequences to signify intelligence in our own communications, another civilization might do the same using light and rhythm. The regularity of the signals hints at intention. Perhaps they represent a message, a pattern, or a form of communication waiting to be decoded. If so, we may be standing at the edge of not only the greatest discovery in science, but the beginning of the first conversation between humanity and a long-lost intelligence. Detecting patterned light sequences from R2 Swan could be comparable to uncovering the first fragments of an alien language. In the world of signal analysis, scientists draw a clear line between random noise and meaningful information. While noise is scattered and unpredictable, true signals carry structure, something you can compress, repeat, and recognize. The James Webb Space Telescope captured light cycles from R2 Swan that don't seem to be random. These pulses might be brief, like beacons flashing every few minutes, or they could span hours with consistent repetition. According to signal theory, if these patterns follow a consistent mathematical structure, they may not only be artificial, they might be intentional. This transforms the question from, "Are the lights real?" to "What are they saying?" That possibility opens up profound considerations about how civilizations might communicate across unimaginable distances of time and space. If these lights are a form of communication, they would likely be built on universal principles, mathematics, geometry, the laws of physics. These are the shared languages of the universe, beyond any culture or biology. Humanity might be standing at the threshold of decoding a message from another civilization. The lights on R2 Swan may not be for navigation or utility alone. They could be an interstellar greeting, sent in the most durable and universal form imaginable. Such a revelation wouldn't just stay within scientific circles. It would ripple across every part of society. Myths of contact, ancient and modern, would suddenly seem far less mythical. Throughout history, humans have imagined gods or beings descending from the skies. In modern times, science fiction has taken up the story. But confirmation of artificial lights would spark a psychological shift unlike anything we've experienced. Every institution, governments, schools, media, even religious organizations would be forced to respond. And no individual could remain indifferent. The very idea that humanity is alone in the cosmos would collapse almost overnight. For some, this might be a unifying moment. A species long divided by borders, ideologies, and conflicts could begin to see itself as one people, Earthlings, living in a wider galactic context. This shared identity might spark unprecedented global collaboration in science, exploration, and diplomacy. Yet, for others, the discovery might spark fear or division. Not everyone would interpret the lights the same way. Some might see them as a threat, others as a divine sign, or as an opportunity to be exploited. Tensions could rise between nations, particularly if access to data or potential alien technology is seen as a strategic advantage. Just as nuclear secrets once sparked an arms race, knowledge of extraterrestrial technology could lead to competition and suspicion. Governments might guard information closely, fearing what others could do with it. The global economy, too, would feel the impact. Markets depend on predictability, and few things are as destabilizing as proof of alien intelligence. Some industries would decline, while others, especially in space technology, would skyrocket in importance. Energy sectors might shift focus if the lights point to new methods of power generation. Education would transform. Fields like astrophysics, linguistics, and information theory would attract new waves of students eager to help decode the lights. A sense of wonder and purpose would infuse classrooms, as young people realize they might grow up in a world no longer isolated in the cosmos. Culturally, the discovery would spark an explosion of creativity. Writers, artists, and filmmakers would rush to interpret the meaning of the lights. New stories would emerge, ones rooted not just in imagination, but in reality. The lights would become metaphors for hope, for the endurance of knowledge, for the idea that even across the depths of time and space, minds have reached out. And then there's the question of scale. If artificial lights are present on R2 Swan, is this a one-time event, or part of something much bigger? Perhaps what we found is just one node in a larger network, scattered across the solar system. It's possible that other comets, asteroids, or icy fragments also carry similar signals, simply too faint to detect until now. Webb's extraordinary sensitivity may have cracked open the door to a far-reaching revelation, that our solar system may be filled with the remnants, or signs, of alien activity. This would change everything about how we view our place in space. Earth and the nearby planets would no longer seem like isolated worlds, but part of a web of presence, where intelligence may have passed before. The endurance of these lights also deserves attention. Human-made spacecraft and satellites tend to degrade after a few decades. But these lights on R2 Swan may have been glowing for centuries or even millennia. That kind of longevity hints at engineering capabilities far beyond our own. It also reflects a different kind of thinking, a philosophy of building for the ages. Imagine civilizations creating technologies not to serve their immediate needs, but to last long after they're gone. To leave behind proof of their existence as a legacy for future explorers. It's a staggering idea that intelligence might persist not only through survival, but through what it leaves behind. And perhaps these lights are not purely functional, but ceremonial, monuments rather than machines. Just as humans build pyramids, carve stone tablets, or launch golden records into space, maybe other civilizations mark their passage with light. If that's true, then R2 Swan is not just an object of science, but a piece of art, a cosmic testimony. It may represent an alien culture's way of saying, across the ocean of time, we were here.